Right, guys, in the last video we got the foot moving as I pressed the left and right arrows to move the foot, and now in this video I'd like to get the physics for the ball working a little bit more correctly. Well, working at all, it's not even moving right now. So I've added a method here that I've called do physics, and the first part of doing the physics will be to move the ball and the foot. So I'm going to put those two statements there. And in the game update method, I'm going to call do physics and pass it the elapsed time parameter. Right, because we want everything calculated over how much time has passed. Okay, so the ball moves a little bit, the foot moves a little bit, and now we need to apply gravity to the motion of the ball. Gravity is acceleration or change in velocity of the ball in the y direction, specifically down. So we're going to say ball dot get y velocity, and we're going to set it to, sorry, I don't want to get the y velocity, I want to change the y velocity. So set y velocity, I'm going to set it equal to whatever the ball's y velocity was, plus a little bit more speed. Now how much speed? Well, I'm going to say gravity times the elapsed time. If I was trying to do physics really, really correctly, gravity should technically be 9.8 meters per second squared. Although I'm not really measuring things in meters in this game, I'm measuring things in pixels per second. So what should my acceleration in pixels per second squared be? I have found that in my experience, an acceleration of 100 pixels per second squared is sort of a nice gravity. Run that, and you can see the ball starts accelerating. It's moving fairly quickly when it gets to the bottom of the screen. No collision with the foot yet, and so it passes right through. Okay, well, let's fix that. Our game update is going to have three main things that it needs to do. Handle keyboard input, done. Do physics, sort of done. Handle physics. And the last thing, check for collisions. Right? Check to see if there's a rebound of the foot of the ball from the foot. In fact, we wrote that into the sprite class to see if two sprites are touching each other, so we can very easily check to see if there's a collision between the ball and the foot by saying if ball is touching foot, if they're touching each other, then there's a collision, and we would say we want to do the rebound from foot method. I'm going to separate this out as a method because we want a place to run all the calculations for how should the ball rebound from the foot. Void rebound from foot. Now, in a very, very simplistic sense, I could say get set y velocity and make it equal to negative ball dot get y velocity. So just turn the ball around and send it back in the opposite direction. There it goes, although it doesn't make it a very hard game because the ball will never do anything but bounce up and down. If I move the foot slightly off to the side, still just straight up and down, right? Of course, if I move the foot totally out of the way, well, that wasn't totally out of the way. Totally out of the way, the ball will just pass through it, and it's not going to come back. That's maybe not the most interesting game, so here's some code that does a little bit more interesting rebound from the foot. I'll just bring that up on screen, and you can pause to copy the code. In a sort of hand-waving, very general sense, what I'm doing here is checking to see where is the ball's location in relationship to the foot, like how close to the edge of the foot is the ball, and adding a little bit of a randomness to that calculation to make things a little bit more playful in the game. And then I'm checking to see how fast the ball is moving, and what angle. I'm calculating a new angle that the ball should bounce at, and that is not based on any physics at all. I'm just making that up based on like how far across the foot the ball touches, and I'm giving it an angle between 0 degrees and 180 degrees, or between 0 and pi by 2. Or sorry, 0 and pi, if you're measuring in radians. You could be more accurate about this, although this seems to work fairly well. And since this is a pretty simple game, it seems to work pretty well for this simple game. And now gives us a nice bounce to the ball. But you notice, if I hit it off the wall, it's just going off the wall, and that's not coming back. All right, so where can I handle rebounding from walls? I could do that in checking for the collisions. I'm going to handle it in doing the ball physics. So I'm just going to add in some extra rebounds here. I'm going to check to see if the ball's X location has gotten to the edge of the screen. So if the ball's X location is greater than or equal to, I would advise you not to use equal to here, because quite often the ball will step like, half a pixel beyond what you're saying as the size of the screen here. And then the equal to won't trigger. Always use greater than or equal to, or less than or equal to. So the ball's X location is greater than or equal to the width of my screen. Remember, I have this particular one set at 600 pixels. 800 pixels wide. And the width of my ball, just going to check that really quick. I believe it's 30. The width of the radius of my ball is 20 pixels wide. So I'm going to check for greater than 800 minus 20, so 780 pixels. If I go larger than 780, then what should happen? Turn the ball around. Ball dot set X velocity. And the rebound here is very simple. I just want it to go like exactly the opposite direction. So ball dot get X velocity. I want to go the opposite direction, so negative that. Right? That's if the ball hits the right side of the screen. What if the ball hits the left side of the screen? So ball get X location is less than or equal to 20, which is the radius of the ball. So remember, the ball's location is set by the center point of the ball, and I want it to look like it's bouncing when it hits the edge of the ball hits the side of the screen. So that's why I'm using less than or equal to 20. Same calculation, set the X velocity equal to negative the X velocity. Let's see if we can get it to bounce off the edge of a screen here. There it goes. Nice. And get it to bounce off the other side. Right, nice. All right, so that's looking pretty good. Now, the last thing I want to do is also make sure that the shoe is not able to move off the edge of the screen. Now, for checking the shoe, what I want to do is, okay, very similar calculations here. If foot dot get X location is greater than, now this is going to be 800 minus the size of the shoe. What was the size of the shoe again? The shoe has a X width of 30, or an X radius of 30. So I'll do 800 minus 30, so that would be 770. If it's greater than 770, the shoe's not going to bounce. So I'm just going to set the X location to 770. Essentially saying, like, that's the edge. You can't go further than that. And then if foot dot get X location less than or equal to 30. Foot dot set x location equal to 30. Now that's the width of the actual rectangle containing the shoe. As long as my shoe is at least fairly close to the size of that rectangle, then that should look just fine. That's good over there. Missed the ball, but doesn't matter. And over on this side, that's pretty good over there too. All right, so now we have the shoe contained to the screen and we have the ball contained to the screen. Right. The last thing that we would need to check is if the ball moves off the screen on the bottom, then that's game over. We're going to get to that in the next series of videos where we start talking about how to separate this game into several different screens. A playing screen, which we've been developing up until this point, a title screen, and a game over screen. Right? And once we have the separate screens sort of built up, when the ball goes off screen, we'll transition from this scene where we're playing the game into a new scene where it's game over because you let the ball fall and you lost. All right, see you in the next video.